When we go to solve quadratic inequalities, the first thing you're going to be asked to do is to graph the solution of a quadratic inequality on a number line. So here we have the equation, well, inequality technically. X squared minus 2x minus 15 is greater than or equal to 0. So this right here represents some type of graph, some type of parabola, which we could easily graph that on our calculator. We'll do that here in a second. Don't cheat, don't do it yet. But let's try to think about where those important critical values are. Where were the critical values on the graphs that we just did on our calculators?
Bottom, or right below.
Well, so when we were looking at the graph, where was it changing from positive to negative at the x-intercepts? How do we find x-intercepts? By solving, by graphing, by completing the square, by factoring possibly, by the quadratic formula. So the first thing we want to do is we want to find your x-intercepts. To do that, we're going to set our quadratic form equal to 0. Let's first ask ourselves, is that factorable?
No.
I think it is. Are there factors of negative 15 that add up to negative 2?
Oh, yeah.
5 and 3, which one's the negative?
I was thinking perfect square.
Yeah.
5 is negative.
5 is negative. So we get x minus 5, x plus 3. We could easily have completed the square there. Just would have been maybe a little bit more work. So what will be my x-intercepts?
Negative 5 and 3.
Positive 5, negative 3. Good. All right, so can we make a number line? Hopefully. There's my number line. Let's put negative 4, negative 3, 2, 1, 0, 1, 2. I'm going to run out of space. We need to get all the way up there to 6, 3, 4, 5, 6. Okay, so I've got my smallest number on there. I've got my largest number on there for my x-intercepts. So that means something crucial is happening at those two values. Because it's an equals to, in my original inequality, I'm going to put a closed dot at negative 3. I'm going to put a closed dot at positive 5. I guess I should be doing this in a different color. We're going really neon here. Negative 3, 5. Can you guys see that green? I just realized that's probably hard to see. Yeah, you can see it. Why am I in neon colors right now? Can you see the yellow better? Which can you see better? Green. The green? Okay. All right, so we'll stick with the green. So now let's think about, that wasn't a good color. Let's think about where would this graph be positive. So what I want you to do is on your graphing calculator, go back into that y equals screen. We're only doing this till you get the hang of visualizing what the heck is happening. So type in x squared minus 2x minus 15 into your y equals. You're not going to need to do this every time.
Can we get rid of what we have in there?
Yep, erase what you got. Get rid of that, come back to that later. Y equals, what was it? X squared minus 2x minus 15.
When I press graph, it says error.
Well, you're probably not typing something in correctly. Are you using a minus instead of a negative? Sometimes that gives a common error. Did you type it in like this?
Use
Y
the
equals x
negative.
squared minus 2x minus 15.
Wait, use the negative.
Don't use a negative for a minus
Use
sign.
the minus. Yeah, I've been using the minus.
Does yours look exactly like mine?
Or is plot?
Yeah, I was doing something like Yeah, that's what mine
And then
does.
we'll go to an error as soon as the graphs
What does the error say?
see that.
So do you have a stat plot on? Go to
Oh
second
no, I
y
know what
equals.
it is. Wait, is it still doing that for you?
Yeah.
It's the thing in front of it. I didn't even notice that. Wait.
All right, so we're getting this graph? Okay, so we were correct in our intercepts being at -3 and 5, right? So since the original problem was asking for where the graph is greater than or equal to 0,
See, I like
where is my graph positive? Is it positive between these two? No. So it's positive on the outsides, right? Everybody's with me on that? So what we're going to do on that number line, right, how do we show solutions?
That's so weird.
Think about, oh, I don't want to see emails from Mr. Stopper. Think about when we smushed this down onto the x-axis, we're taking the positive versions and smushing it down. So it would be going out that way. If I smush this up, then that would be the negative part. Does that make sense? All right, so if we go back to our solution that we were working on, we had our number line drawn. So now my solutions on the number line are going to occur from -3 to -infinity. So in that direction. And then from 5 to positive infinity. Okay, so graph. No, they're only going to have you guys graphing it. I don't think that's more of an advanced algebra topic, is writing it out.
There we go. Nice.
That's what was wrong with it.
You figured it out?
Yeah, there was like Y9s. There's all the ones on the bottom.
Yeah, no, they're just going to make you guys graph it. Well, okay, so they're writing it like this. So we could do, so the solution would then be x, I don't know what happened to my old, like, just regular color. There we go. So we could say x is less than or equal to -3, or x is greater than or equal to 5.
You have to do that for?
Yeah, they're going to have you do that. So this is what it would look like on just a number line. And my solutions would be, so any number less than or equal to -3, if I plug it in there, will get me a value greater than or equal to 0. Or any number greater than or equal to 5 is going to get me a value greater than or equal to 0. If this would have changed to, let's say, a less than or equal to 0, then where would your graph been negative? In between, which would have been this whole solution area, right? And then how do we write our answer for everything shaded in between? Remember how to do that? -3 less than or equal to x less than or equal to 5. You guys remember those compounding inequalities back in the day? Remember our oars? Holes in there rowing his boats, his oars. That's why that's an oar. Okay. Yes? Kind of? Maybe?
A little bit.
All right, let's try another one. So I don't know if I have another one. I might just make one up. Let's make one up. Let's do x squared plus 4x minus 6 is less than or equal to 0. So it's the first thing we should find.
Equal it to 0.
Yep, equal to 0, find your intercepts. Is that factorable? They're probably going to give you ones that are factorable just to make your life easy. Factors of -6 that add up to 4.
There aren't any.
Oh, I didn't, let's change that to a 5. Then it would work out.
3, 2.
I don't know why I was thinking 4, 2. That would be 8. My bad. Negative 6. So positive 6, negative 1.
Mm-hmm. Oh, wait.
Yeah.
Couldn't you do 3 and 2?
But it's a negative 6. So they need to be opposite in signs,
Oh, okay.
which would get you to 1. So x minus 6, x plus 1 is equal to 0. So what are my crucial x-intercepts?
6 negative 1.
X plus 6, X minus 1. Yeah.
Yes. My goodness, I am so off my game. Thank you guys. What did Max say last time? Just making sure you're paying attention.
Negative 6.
Negative 6, positive 1. We'll get it there. Okay, put those on a number line
Wait, why is it a plus 6?
because it's a positive 5.
So you made it a negative 6
Oh,
here.
okay, okay. Well, no,
But when
I was
you
looking on
but when
the
you
side.
solve it,
Yeah.
got it. So when you solve it, the 0
Yeah,
of that
no,
would be
no, no.
negative
I
6.
was looking at your side.
Right
thing,
here.
so
That's the negative 6 you're asking about, Brandon?
Yeah.
Yeah. So if you, what's the 0? X plus 6 equals 0. You would subtract 6. So it'd be negative 6, positive 1. All right. So negative 7, 6, 5, 4, 3, 2, 1, 0, 1, 2. I'm being lazy and not putting all my numbers in. Open or closed dot? Closed. The only thing that would change is if it wasn't an equals to, it would be an open dot. All right, so dot at negative 6, dot at 1. Now where would my graph be negative? Now here's your clue. Would this parabola be facing upward or downward? Upward. So if you do a quick sketch of this, we're at negative 6 and positive 1, and it's facing upward, right? I don't really care where the vertex is or anything like that. So the negative part would be in between. So I'm going to shade in between. How do I write that as a compound inequality? Is less than or equal to x, less than or equal to 1. If my parabola would have been a negative a, and it would have been upside down, then if it was positive, it would be in between. So it's kind of opposite. So you have to think about the type of graph that you're going to be seeing. If it was a negative a, and my graph was facing downward, then my positive is going to occur between the two values, and my negatives are going to occur to the left and to the right. Okay? All right, we'll practice some more.
How do you know if we're asking for the positive or if they're asking for the negative?
The original inequality is going to tell you that.
Okay.
Okay? Should we do
So
one
what is
that's...
that one asking for?
It's asking for where it's positive. So
Okay.
did I do no, that one was positive. The one we just did was negative
Okay.
because it was less than. All right, let me give you one that goes, I don't give you any that are upside down. Isn't that nice for your homework? Okay, so let's look at this one. Some quick tricks. Let's write out the quantity x minus 2 squared is greater than or equal to 0.
Okay.
First thing we need to find.
X-intercept.
X-intercepts. So that means we're going to set that whole thing equal to 0. How do you solve that? Square root both sides. Square root is 0. It's plus or minus 0. What's your next move? Add 2. What's 2 plus 0 and 2 minus 0? 2. So my only x-intercept is 2. Now envision this graphically. If my only x-intercept is 2, is this graph facing up or down? It's up. Because remember vertex form, what technically is my A right now? My A is really 1, which is positive, so that means it's going up. So I want to know, when is this graph greater than or equal to 0? Is there any part of that graph that's negative?
No.
No. So what will we say?
None.
All real numbers.
All real numbers. So if we were to graph it on a number line, which you're not going to have to do that, but let's just quickly look at this. Where is everything greater than or equal to 0? Well, it's the whole entire number line. So we can either write out all real numbers, or if you want to use the symbol all real numbers, that's up to you.
So would that always happen when it's equal to 0?
If it's equal to 0, yes. Now let's go through all the other different scenarios. What if I change this problem? Can I erase this?
Yeah.
What if we changed it to x minus 2 squared is less than or equal to 0?
Be all negative numbers.
So again, did my x-intercept change?
No.
My x-intercept is still at 2. Is there any part of that graph that is negative?
No.
No. Is there any way to square any number and get something less than or equal to 0?
No.
No. So what will we say? No solutions.
So if it's less than.
Less than.
then it's
No solutions, yes. If it was just greater than, so let's go back and do just x minus 2 squared is greater than 0. Can I now include my x-intercept of 2? At 2, is it greater than 0? No, because 2 minus 2 is what? 0. 0 squared is 0. Is 0 greater than 0? No, that's a false statement. So this would be all real numbers excluding which number? Good. So we're going to say all real numbers. I'm going to put a little bar here. This bar stands for such that x cannot equal 2. Or if you just want to write it out, all real numbers excluding 2, you can write it out if you want. But if you want some notation, when you see a bar like that, it means such that. So it's all real numbers such that x cannot equal 2.
Because it doesn't have a line under it.
Because it's not equals 2. Huh? Oh, for probability? Yeah, this is getting us into set notation. I'm advancing your notations here. It does mean given also when you're talking probability. But if you see something like that, if you just write x cannot equal 2, I will know exactly what it is you're talking about. Okay? All right, so now let's actually graph them and do some shading. Let's go back to your calculator. And look at how cool our calculators can be. Go back to your y equals screen. We're not even going to change what it is that we're typing in there. So does everybody still have x squared minus 2x minus 15?
Yeah.
So now what I want you to do is I want to move your cursor, so using the left arrow, move your cursor to the left side of your y1. Now mine's fancy because I have different colors. Right now, you're telling your calculator, I just want a singular line. If I wanted to change this to, let's say, greater than or equal to 0, now let's think about our shading. If I want to be greater than, are we going to shade up or below? We're going to shade above. So I think if you hit the enter button, oh, mine's getting really fancy. If you hit the enter button, does it change the way that your thing looks? All right, so we want to change it to top right for above. So keep hitting enter. It should work you through all of these different things. Yeah? So you've got either below or you've got above. Does everybody have it on above? Kind of looks like a triangle there, top right.
Yes.
Okay.
Triangle facing
There's a big
northeast.
graph.
Yeah, northeast. Then hit graph. Let's see what that looks like.
Whoa, that's so weird. That's actually
Yeah, that was pretty cool.
So now it shaded everything inside the parabola. Where do you think it would shade if I put it on the lower left?
everything outside.
Everything on the outside, and we would use that when we needed everything that was less than or equal to. So your calculator does this stuff, which is kind of cool, I think. All right, so let's do it by hand, which is not quite as much fun. All right, so here we go. Let's graph by hand. So you're going to be told graph on a number line, and that's when you will be clued in to say, oh, I got to put it on a number line. If it just says graph the solution, then we're going to make it two-dimensional with an x and a y axis and physically graph it. Okay, is this in vertex form?
Yeah.
Yes. Someone tell me what my vertex is from vertex form.
It is
My vertex is
X.
it -2 or +2? Remember?
Make it positive.
Yep, because remember our vertex form was y equals a times x minus h plus k.
What?
When we completed the square, remember we did vertex form
When?
back in 2 weeks ago, and we did completing the square. I don't know when it was.
2 weeks ago?
I don't know. Was it before? It was probably before break. So my vertex is 2, 1. What's your axis of symmetry? Yep, y equals, or x equals 2. Okay, so let's make a lazy graph. All right, can we plot 2, 1?
Yeah.
Hope so. 2, 1, it's right there. Dotted line, axis of symmetry. What else do we need to find to be able to finish this graph? Let's find another point.
Oh, X.
Someone give me another nice x value. Do we want to use 1 or 0?
0.
Let's use 0 because that's less to think about. What's 0 minus 2?
-2.
Squared. Plus 1. 5. Is everybody okay with that?
Yeah.
Can we plot 0, 5?
Yes.
Sure. Plot 0, 5. Reflect it. All right, that's enough. We'll call that good. Solid or dotted line? Solid, because of the equals to. Now, I want my y value to get larger. So am I going to shade inside or on the outside? Inside. If I were to shade on the outside, does everybody see how if I shaded out here, my y value would keep getting smaller? Yes? If I shade on the inside, it's only keeping my y value from getting larger. So I'm going to shade on the inside. Okay? So if it says graph on a number line, that's when you put it on a number line. If it says just graph the solution, then you have to physically graph the parabola and then do your shading. All right, last one. Y is less than or equal to x minus 1 squared minus 5.
Will it always be in vertex form?
They give you one that's not, so then you would just do negative b over 2a. What's my vertex? 1, -5. My axis of symmetry is x equals 1. Let's make a lazy graph. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1, 5. Or 1, -5. Where am I going? -5. Axis of symmetry. Okay, let's find another point. 0 is a good one. We plug in 0 into the original equation. 0 minus 1 is -1. -1 squared is 1. 1 minus 5 is -4. So let's plot that. Reflect it over. Solid or dotted? Solid. Since I want to be my y less than, where are we going to shade? Outside. Good. There it be.